at the T-minus 12-minute mark to liftoff and goes through each operator on console in our Mission Control Center and in our Range Control Center at the launch site. We're coming up to the pole now, set to begin in just a few seconds.
And to all operators, LDN mission code, we're proceeding now with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNCs go.
Recon.
Recons go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Net is go.
RF.
RF is go.
Copy, thank you. MM.
MM is go.
And LD-SUB.
LD-SUB is go.
The go, no-go sequence is complete. We are currently T-minus 11 minutes and 9 seconds and counting. We go for a terminal count auto sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
Greens across the board there from our launch operators during that go, no-go poll, with the team moving ahead with all remaining launch operations ahead of liftoff. Our launch time remains set for 3:15 p.m. local time or 03:15 UTC in approximately 10 minutes 39 seconds. While all eyes are on Electron's launch today from the Southern Hemisphere back in the United States, we have a team working steadily on a mission of another kind for our new big rocket, Neutron. We have the first of our new Archimedes rocket engines on the test stand at the Stennis Space Center in Mississippi, being prepared for its first hot fire in the coming weeks. Now, we'll have 9 of these engines powering the first stage of Neutron to produce a total combined liftoff capacity of 1,485,000 pounds of thrust. In fact, one Archimedes on its own produces the equivalent of about 3 entire Electron rockets. Now, since the engine arrived in Stennis a few weeks ago, the team there has completed numerous checkouts and activations of the test site's infrastructure and its supporting systems. The site's flame stack has been burning bright in preparation, and we can't wait to see the engine burning bright too, with its blue flame mix of liquid oxygen and methane. Here's more from the team at Stennis as they prepare for Archimedes' first hot fire.
I'm Nikki Rains. I'm the manager for Rocket Lab's facility here at Stennis Space Center. We just installed the Archimedes engine for the first time on the test facility. So we've got engine system integration. There's piping, valving, wiring going on. That's being worked real time with software. Back in our control room, the human-machine interface, HMI, that we use to control things. Those things are in the final preps and final checkouts. We're ready now to push the engine through final commissioning and ready for hot fire. Rocket Lab came into NASA Stennis with the lease for the A3 stand. It was a historic stand built for the Constellation program in the late 2000s. We've been able to utilize hardware. We've taken tanks, we've taken valves, existing piping, whole existing systems for gaseous nitrogen, and be able to repurpose those systems and put them to work for what we need. It lets us go faster, it lets us save money, and it lets us get that initial operational capability Archimedes needs. It's great for Rocket Lab as a commercial company to be partnered here with NASA. We get to use this facility, so we're taking advantage of the existing hardware and being able to repurpose parts of the stand, but we also have a community of support around us. There's contractors here who know how to build rocket test stands, welding, piping, major big concrete and steel structures. There's people who know how to make rocket operations work. So we got that community of people here to support us, and it's a great place to be for a commercial company to be in the middle of this with all that support and the ability to run our operation. My sincere appreciation for the team that we have here at Stennis, the team globally with Rocket Lab. We've had support from New Zealand and Long Beach and from Wallop. So they've come together here. We put a ton of work in here in the last year, and to see it all come together should be exciting for all of us. The team deserves a huge congratulations from everybody involved that have gotten us this far.
If you want to get in on the next round of engine hot fires, it is not too late to join the Neutron team in Mississippi and California. We have open roles in manufacturing, design, engine development, and more across several states. You should check out rocketlabusa.com for your options. T-minus 6 minutes, 27 seconds to launch. Let's take a look at the Electron rocket for today's mission. Electron is a 3-stage liquid-fueled launch vehicle designed specifically for small satellite missions. And over its 48 missions to date, Electron has deployed more than 180 satellites across various low Earth orbits for science, commercial, and national security missions, including a mission all the way to the moon for NASA. Now, Electron has a lift capacity of just over 300 kilograms to LEO. The rocket stands 18 meters or 59 feet tall, and once fully fueled, weighs 13,000 kilograms or more than 28,000 pounds. The rocket's black look comes from the carbon composite material that it's made of. We use carbon composite across Electron's external structure as well as throughout its internal systems and propellant tanks, which helps to keep Electron as lightweight as possible. Where the rocket looks white is where you're seeing ice form on the outside from the freezing cold temperatures of the liquid oxygen propellant that's being loaded into Electron's tanks. We use a mix of liquid oxygen and kerosene as the propellants for Electron's Rutherford engines. We have 9 of those at the bottom of the first stage and a 10th Rutherford engine that's attached to the second stage. The engines are identical across both stages except for a large expansion nozzle on the second stage Rutherford engine that supports its performance in the vacuum conditions of space. Now, all of our Rutherford engines are 3D printed and battery powered, which makes them unique as far as rocket engines go. Once Electron reaches space, though, it separates its first and second stages to continue the mission to orbit, and then repeats this process again between its second and third stage. This third stage is called the kick stage, and it's what the PREFIRE satellite is attached to all the way through to payload deployment. The kick stage has its own little engine called the Curie, which we use to precisely deploy satellites exactly where they need to go in space. The kick stage will be released at the perigee of this mission's trajectory, which is the lowest part of the kick stage's path around Earth. It's set on an elliptical orbit first, so to course correct to a circular orbit, we wait until the kick stage reaches the other side of the planet and the trajectory's apogee, which is its highest point, close to that 525-kilometer target. Now, once here, the Curie engine will light up to set a circular course around Earth before a few moments later releasing the payload to space and ending the mission for Electron. Now, all of that is coming up shortly, now that we are just 3 minutes and 45 seconds until liftoff of PREFIRE and DICE. It's time to send it over to Mission Control to take it from here for the remainder of the count, and I'll be back with you shortly after liftoff. Go NASA, go PREFIRE, and go Electron.
And to all operators, LD on mission code. From now on, there should be no red flags on your critical LCCs. Recon LD mission code.
LD begun.
Please lock the auto sequence and confirm.
Auto sequence is locked.
Recon, please confirm all expected primary flight computer ASCIIs are green.
That's confirmed.
We go for an auto sequence start at T-minus 2 minutes. LDs go for launch.
Vehicle is fully on internal power. AFTSs are on green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
We are T minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Beginning pitch over. Stage 1 propulsion.
There goes our 49th Electron rocket soaring off the pad at Launch Complex 1 and on its way to space for NASA. We are now 39 seconds into the mission and our first mission milestone is coming up called Max Q. This is when Electron reaches the maximum amount of pressure that will work against the rocket as it powers its way through the atmosphere. We should hear a call out from Mission Control soon that Electron has made it through that structural test.
High voltage battery discharge nominal.
Cleared Max Q.
That's Electron smoothly through Max Q as the mission continues. We are now at 1 minute and 18 seconds into the mission as Electron passes more than 18 kilometers in altitude at more than 2,300 kilometers an hour. Up next are a familiar set of actions that Electron performs to continue the mission. The first up will be MECO, or main engine cutoff, when all 9 Rutherford engines on the first stage throttle back before shutting down. After that is stage
Guidance is
separation,
nominal.
followed by the engine startup on Electron's second stage to carry onto orbit with NASA's PREFIRE satellite. Standing by now to listen out for Mission Control to check off those milestones.
HOS Chathams.
Stage 1 propulsion is holding nominal. Stand by for MECO in roughly 30 seconds.
"15 seconds till staging."
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
That was Miko, stage separation and second stage engine start for Electron. The second stage Rutherford engine is glowing hot and bright as it carries on to orbit, now more than 100 kilometers above Earth and moving at more than 8,000 kilometers an hour. Now, this engine is identical to the sea-level Rutherford engines used on Electron's first stage, with that exception of a larger expansion nozzle that allows for improved performance. Next up is fairing jettison of the rocket's nose cone, and the fairing is what protects the satellite on Electron through flight. But once Electron is ready to be rid of the nose cone, each half of the fairing is designed to rotate on a hinge away from the payload in a safe separation motion. And that action is due now in just a few moments, so let's listen in.
Fairing jettison confirmed.
And there they went. Electron's fairing halves have split and fallen away from the rocket as planned. Now that nose cone is ejected once we reach space and we don't need its protection anymore for the NASA PREFIRE satellite that is on board. We're heading to a 525-kilometre orbit for this mission, but stage 2 will only take us to just over 200 kilometres to our perigee, where we'll separate the kick stage that has the PREFIRE satellite. So another 100 or so kilometres to go for Electron's second stage. We are approaching the next mark in the launch for Electron's second stage, an action that you'll only come across with our rocket called the battery hot swap. The Rutherford rocket engine powering the second stage uses batteries as the power supply for its propellant pumps. Now, those have been running for some time now, so the battery's power levels are running low. And to prevent an engine stall, we swap out those dying batteries with a fresh pack that will keep the engine running its full duration. Now, those old battery packs are ejected once they're done, which you can sometimes see on your screen as they fall away. So watch out for those just after the T+6 minute mark into the mission.
Throttling down.
Battery
Hot swap
jettison
success.
confirmed.
And that is battery hot swap confirmed for the second stage Rutherford engine, called out by the operator in mission control, in which we saw
Stage
on
2
our screen just
propulsion
moments
still
ago.
holding nominal.
Now, with that clean swap, the Rutherford is continuing nominally along its journey, maintaining its current trajectory towards that perigee and moving along at more than 15,000 kilometers an hour. We have a couple more minutes to go with Electron's second stage as we approach its final set of actions with engine shutdown and stage separation expected soon after we tick over 9 minutes into the mission. Seven minutes and 10 seconds into the mission, well over 17,000 kilometers an hour now, and things are looking nominal for that second stage engine burn. The next milestone for this mission will be the second engine cutoff on that second stage, which we're coming up to in just a few moments.
High voltage battery discharge holding nominal.
Stage 2 propulsion is holding nominal.
It's now 8 minutes, 16 seconds into the mission, which means we are coming up on the engine shutdown for Electron's second stage, to be followed shortly afterward by stage separation of the kick stage that is carrying NASA's PREFIRE satellite. The process is practically the same as the first stage engine shutdown and stage separation that Electron performed earlier in the launch. We'll know that it's been successful when we see that red hot engine nozzle on the screen start to turn cold with that successful engine shutdown. We're waiting, though, on the call out from Mission Control for confirmation of those actions.
Guidance is in terminal, 20 seconds remaining.
Seco confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
Successful engine shutdown and a clean stage separation for Electron. The kick stage has been released at its perigee with its attached PREFIRE satellite ready to join the first PREFIRE satellite deployed to space just last week. Now, with the kick stage released onto an elliptical orbit first, it now has to complete its first set of maneuvers to correct to a circular orbit. This involves an engine startup in about 40 minutes once the kick stage completes its first half orbit of Earth. We'll take a break in the webcast now, but come back live for that engine startup, as well as the final milestone for this mission, payload deployment for NASA's PREFIRE satellite. We'll see you back here soon.